Welcome to the Eyetrace 2014 tutorial. In this video, I will explain you the idea and structure of Eyetrace and show you some features that could be interesting for your work. Eyetrace 2014 has its origins in a cooperation between the Department of Art History at the University of Vienna and the Computer Science Department at the University of Tübingen. Vienna has been working with the comprehensive bit aging software tool Eyetrace2014 and Tübingen worked with the unstructured collection of newer evaluation and visualization scripts. So we combined the advantages of both, kept the name Eyetrace, and developed a new and multifunctional tool Eyetrace2014. To make Eyetrace adaptable for as many eye tracker models as possible, we decided to prepend a data preprocessing tool Eyetrace Butler. The Butler contains plugins for different eye tracker types and converts the individual file formats into a unitary one. These files thereafter can be used for working with Eyetrace 2014. Now I will show you an example for preprocessing data using Eyetrace Butler. After the start screen disappears, Eyetrace Butler provides you the list of available plugins, of which you choose the one you need. In this example, we use the plugin for the SMI Red 5 eye tracker and submit. In this area, you can add the raw data you want to convert. And if necessary, remove single files or clear the whole list. The second area links to the subject index, which contains all available information about the test person. The Butler relates this information to the eye tracking data and therefore allows Eyetrace 2014 to use this information for evaluations. The subject index is a comma-separated value file. The important columns are the subject ID and the dominant eye. All other columns are optional and will just be carried over. The path to the image folder is necessary to load the images as background pictures in Eyetrace 2014. To avoid to generate data for which the image file is missing, it makes sense to tick the checkbox Convert only for available pictures. The output folder just denotes the path where the Butler saves the output files. For many plugins, Eyetrace Butler offers a quality check that prints the percentage of valid data points for every eye, as well as the number and mean length of invalid sections. If you want, you can enter a prefix for the file name here and finally start the conversion. The interface of Eyetrace 2014 is divided into three parts. On the left side, you see a table of your imported examinations, including all information of the subject index. This table can easily be sorted and filtered by the buttons below the table. If you want to exclude an examination from evaluation or visualization, just uncheck it. For unchecking or checking all examinations at once, use the buttons below the table. In the middle of the graphical user interface, you see the visualization area. Here you can load a background image and make the results of your calculations visible. On the right-hand side, there is the command center, where you import your data, change the calculation parameters, and perform calculations. Adapt the parameters for the visualization, calculate statistics, and finally, export your results. After converting, the raw eye tracker files with the butler, you can import the resulting data files and their information will be added to the table on the left side. Eyetrace2014 provides a multiplicity of calculation algorithms for fixations in saccades, fixation clusters, cumulative clusters, areas of interest, short AOIs, and even scan path comparison. Fixations can be standardly calculated by a simple shifting algorithm, by a probability algorithm based on a Gaussian mixture model, or an algorithm that separates fixations in saccades by the velocity of the gaze movement. After choosing the algorithm you want to use, adapt the parameters or keep the default settings and click Calculate. Fixation clusters represent an accumulation of fixations on a specific region. This version of Eyetrace provides on the one hand a standard algorithm comparing every fixation to all others, and on the other hand the more flexible mean-shift clustering algorithm. You can calculate fixation clusters for individuals as well as for a whole group of subjects. As AOI, you can define a specific region on your image that seems to be interesting for your evaluation. For defining a new AOI, click Add AOI, define the AOI on your image, name it, and confirm it by clicking Accept AOI. You also have the possibility to convert the cumulative heat map of fixation clusters into AOIs. Of course, you can also store the AOIs on your disk or load previous stored AOIs. The current visible visualization is always depending on the markers of the timeline. Sliding these markers reduces the visualization to the gaze points inside the marked time slot. The basic gaze points can be visualized as points, heat map, or shadow map. Regions with many gaze points appear red in the heat map and erase the black shadow of the shadow map. For the fixations, there is also the heat map or shadow map visualization option, but in this case, only the points that are part of a fixation are handled. Visualizing the fixations as circles draws a standardized circle around every fixation center. Ticking the option Depend on duration sizes the circles depending on duration of the fixation, or more specifically, depending on the number of gaze points this fixation includes. The elliptic illustration is based on a principal component analysis and shapes the fixation more precisely, referring to the included gaze points. For fixation clusters, the visualization options are the same as for the fixations, but you can additionally choose the circle or elliptic mode for cumulative clusters. Saccades can be printed as arrows or simple lines by removing the tip of the arrow. There is also the ability to visualize the length, number, and duration of saccades by generating an angle star. But in this tutorial, I won't get detailed into that. The visualization of the saccade bundles is dysfunctional in Eyetrace 2014 and will be implemented first in the next Eyetrace version. The visualization of the AOIs can be simple or very fancy. The outlined visualization just makes the defined AOIs visible in the image. The AOI transitions diagram is a very new feature of Eyetrace and enables the interactive visualization of gaze transitions between different AOIs. With the general gaze statistics, you can calculate the horizontal and vertical gaze activity as well as minimum, maximum and average speed of the gaze movement. These statistics are independent of any calculations and refer to the basic gaze points. The AOI statistics provide several additional information about the gaze behavior regarding a certain AOI. After calculating and visualizing in Eyetrace, you of course can export your results. The visualization export captures the current visualization screen and is able to store it in several different image file formats. If you want to attach your calculation and visualization parameters, you can do that by checking Append Calculation Parameters. If you want to export the visualization of the AOI transitions graph, you can also do that in different file formats. For exporting the calculated data of fixations, fixation clusters, cumulative clusters or events, a data format that includes fixations, saccades and the invalid sections, you can do that for both or for only one eye. Adding a file prefix helps you to retrieve your data more quickly if you later need it again. For the statistics and the matrix of the AOI transitions diagram, the export works exactly as in the case before. I hope I could give you a short but helpful overview about Eyetrace 2014 and wish you success for your work with this tool.